Our assignment for today, or our lesson for today, is systems of equations using the elimination method. Now, there are three methods of solving for a system of equation. If you remember, a system of equation is when you have two linear equations graphed on the same line. What you're looking for is the intersection point. For example, if you had two lines, that's one, that's another line. You're looking for the point where they intersect, right there. That's the point we're trying to solve for. And when we say solving for systems of equations, that's what we're talking about, finding that intersection point. Now, there are three methods. One of them is by graphing, what we've just done right here. The other method is using substitution, which we teach in a different lesson, and this one using the elimination method. Now, the process is this. Identify the variable that has the same coefficient but different sign in each equation, and then add down, adding the two equations so that one variable will cancel out. First of all, coefficient. This is a -2. It's a coefficient of x. This 2 is a coefficient of x. This 3 is a coefficient of y. The coefficient of this variable, this y, there's not one, so what we can do is call it a coefficient of 1, or put a 1 in front of that y. Now what we're looking for is variables, x's or y's, that have the exact same coefficient, same number, but different sign. Notice the x's, same number, 2's, but the signs are different. One's negative and one's positive. So here's what we're looking for. We want that type of setup. Now, let's add down. What we mean by that is we take this x, the coefficients, and we add these equations down. This one and this one. -2 plus 2. Well, that should make 0, meaning that those right there cancel out. Okay, now let's add this down. We have a 1 in front of that y. 1y plus 3y gives us 4y equals -25 plus 5 gives us a -20. All right. Now let's solve for y. 4. Y then is equal to a -5. Now, if we're looking for that intersection point, we require both an x and a y value. We have the y value, it's a -5. Now we must find the x value. So we take the value of y, substitute it back into one of the original equations. Let's take this one here, rewrite it, 2x plus 3y equals 5. And in the place of y, let's substitute the value of y. Okay, 2x plus 3 times a -5, that would give us a -15 equals 5. Now, let's combine the 15 and the 5 together by adding 15 to both sides. That will cancel. 2x then is equal to 20. Divide by 2, and that gives us x then is equal to 10. So these two linear equations intersect one another at x is 10 and y is -5. Now notice the process, or why we're doing this. When you have two variables in the same equation, it's impossible to solve for that equation without knowing one of the values. So we require two equations. And why we require two equations, our intent is this very thing, to add the two equations in such a way that one of the variables will cancel out, like our x's here, leaving us only one variable to solve for. This is the purpose with substitution as well as elimination. Now we can solve for any equation that has only one variable and an equal sign. So with that, we solve for one variable. Once we have that value, then we plug it back into the equation, leaving us again only one variable to solve for, now this time the x. Solving for the x gives us a value for x, which then gives us our final solution, or our intersection point. Let's look at another problem. This one right here. Again, the steps are to identify a variable that has the same coefficient, different sign, and then add down. Well, notice here, negative 4x minus 5y and negative 4x minus 8y. Notice the x's have the same coefficient, but their signs are also the same, which is not exactly what we would like. So, what we have to do is manipulate or make a change to one of these equations in such a way that it would keep the signs, or keep the coefficients the same, but change their sign. Generally, the easiest way to change the sign of any number or equation would be to multiply by a negative 1. So let's do that to this first equation. And let's rewrite it over here. Negative 1 times negative 4 gives us a positive 4x. Negative 1 times a negative 5 gives us a positive 5y. And negative 1 times a negative 6 gives us a positive 6. Now let's rewrite this equation underneath it. Okay, notice we now have a variable with the same coefficient and the signs are different. These will cancel out when we add down. Now we get a negative 3y equals negative 18. Divide by negative 3. Y then is equal to positive 6. Okay, with that, let us take it and substitute it into the equation. Let's do the bottom one this time. Negative 4x minus 8y equals negative 24. In the place of y, let's substitute the value of y. Negative 4x minus 8 parentheses 6 equals a negative 24. Okay, negative 4x, see here, minus 8 times 6 is 48 equals a negative 24. Now, add 48 to both sides. You get a negative 4x is equal to 24. Divide both sides by 4. X then is equal to a negative 6. So, our intersection point is negative 6, comma 6. Let's take a look at another possibility, type of problem you may encounter. Look at this one. Again, we're looking for a variable that has the same coefficient but different sign. Notice there are no variables with the same coefficient, 4 and 7, 1 and 4. So here's what we have to do is rewrite or multiply through. Just like we did the previous one, we multiplied through it with the negative 1 to change the sign. We can also multiply the entire equation by a number if need be to get the same coefficient. The easiest one here would be to multiply the top equation by 4. Because notice what would happen. 4 times x would be 4x, giving us positive 4x on top, negative 4x on bottom. Alright, let's do that. 4x plus 4 times 4 would be 16y equals 4 times 12 is 48. Now let's rewrite this beneath it. Oh, that should be a negative. Okay, let's add down. Notice our x's will cancel out nicely. And these, positive 16, negative 7, would be a 9y equals 36. Divide by 9. Y then is going to equal 4. With y being 4, let's take that and substitute in the equation. Let's take the top one this time and rewrite it. X plus 4y equals 12. Notice I took the original equation. You can take this one, or one of these to substitute the value to find your other variable. Doesn't matter. x plus 4 parentheses and put 4 in the place of y, 12. Okay, 4 times 4 is 16, so then x plus 16 is equal to 12 minus 16 on both sides leaves us with x then is equal to a negative 4. Okay, so we have negative 4 comma 4. I notice that all of our problems thus far, we've always solved for the y variable or canceled out the x first. It doesn't have to be that way. You could easily cancel out the y's just as well and in the same fashion. Again, our rule is to find coefficients or variables that have the same coefficient, different sign. Well, here we have a problem where neither coefficient matches nor the signs match. Well, I shouldn't say that. Neither coefficient matches. Now let's look here. If I was to multiply 9 by a number, or this equation by a number, would it match 10 in any way? There's no number that I can multiply by 9 to make 10. Nor is there any number I can multiply by 2 to make 7. So now I must think of a number that both top and bottom can be multiplied by to make, I need to think of a number that I can multiply the top equation and the bottom equation into so that the coefficients will match. I don't know if that makes any sense the way I said it. But here's what we need to do. If we think about it, 2 and 7 both will multiply to make 14. So let us multiply the top equation by 7 and the bottom equation by 2. What that will do is that will force this 2 to become a negative 14 and force this 7 to become a negative 14. Now here's where we have a problem here, however. If we multiply those, we will have the same coefficient, but we'll also have the same sign. They're both negative. So in this situation, we must multiply one of these by a negative number. For example, let's take this 2, it's a smaller one, and let's multiply it by a negative, or this bottom equation by negative 2. So I'm going to, let's see here, let's rewrite this. 7 parentheses negative 2x plus 10y equals 4. Now let's multiply through. You get a negative 14x plus 70y equals 28. Alright, let's do this one now. But let's do it with the negative 2. Negative 7y minus 9y equals 14. Negative 2 and a negative 7 makes a positive 14y. Negative 2 and a negative 9 makes a positive 18y, positive 14x. Positive 18y equals negative 2, 14 makes a negative 28. Now let's bring these over. You have 14x plus 18y equals negative 28. Notice, negative 14, positive 14, my x's cancel. Add down, you get 88y equals 0. Negative 28 and negative 28 makes a 0. So then the y is going to equal 0 when you divide by 88. With y being 0, take your value, plug it back into one of the original equations. Let's take the top one, 2x plus 10 parentheses 0 equals 4. So that's going to be 2x, negative 2x, plus 0 equals 4. Divide by negative 2. You end up with x then is equal to negative 2. The point where these two lines intersect is negative 2 comma 0. The rules are these. Make sure that you have a variable that has the same coefficient, different sign, and then add down. If you do not have that already set up for you, same coefficient, different sign, then you must multiply either one equation or both equations by a number in such a way that your variables will create or will have a coefficient, the same coefficient and different signs, so that one, either the x or the y, will cancel out. That concludes our discussion.